Okay, T10ers, today we're going to look and see how a relay works. Why do we need relays? We need relays because we use a small current to control a large current. Okay, part of a relay consists of a switch, and this is a crudely constructed switch. You can see I'm going to close the switch and the light goes on. Well, the normal purpose of a relay is a small current controlling a large current. I'm going to use a large current to control a small current. This may look familiar to you. This is a rotor out of an alternator, also called a field winding. It would normally have brushes here, and the voltage regulator controls the current, which controls the strength of the magnetic coil, which controls how much the alternator is going to charge or not. So that's how we keep it in our target voltage range on a car. I'm going to put this electromagnet here, and I'm going to show you where I'm going to energize it, and that's how a relay works. A relay has a coil just like this field winding, a magnetic field. We create it, and it turns the switch and it turns it on. That simple. But I want to show you something else too, and what happens when a magnetic field collapses. You might think that it takes more current to spark a wire, where you're going to watch me. I'm going to connect it, and then I'm going to disconnect. You see a pretty big spark. Connect, little spark, big spark. That's the magnetic field collapsing on itself, and that's what we call a voltage spike. If you look in the construction of a relay, you'll see that usually there's a 1K or 1,000 ohm resistor to clamp this spark so it doesn't go back to the computer and confuse the computer with a spike. Hope you enjoyed this.